Yes, you proceed.
Yes, sir. Good evening, everyone. I'm Mohan Ram from EEE Department of Dr.N.G.P. Institute of Technology. Today, we are going to see about a topic called SCADA and power system automation. First of all, I will give a clear information and a clarity to you about SCADA and its uses and how it is used in automation in power system. So these are the contents like introduction, what is SCADA, and the components like PLC, RTUs, HMI, and the working of SCADA and the use of SCADA in power system and power system automation and the system components of power system. So at last the advantages and the disadvantages. So next, see, this is the introduction to SCADA. At 1960s, early 1960s, a control system called VisiCode was developed by Westinghouse and Electric Company, Northern Electric companies. So, by the evolution of telephone system and coding schemes, Westinghouse and North Electric companies are able to develop VisiCode. So, SCADA was not invented or suddenly found, but it was gradually developed from VisiCode so that it can automate the industry process. So the term SCADA was coined at the year 1970s, at the early 1970s. And next, see, first of all, what is SCADA? SCADA is nothing but a control system which can monitor and which can monitor the system by collecting the data from the process. So it is called as a software which is called Astra, and it also has some hardware elements like PLCs, RTUs, which we are going to see in upcoming slides. So it is also programmed by languages like C plus and other derived languages. So SCADA system is connected to sensors, valves, and the objects in the industrial process through HMI. HMI is nothing but human machine interface, which is the communication or the interface between the human and the objects in the factory or the industries. So it collects the data, the SCADA system collects the data from the process, and so it can monitors and gives commands to the process to proceed the process and to get the higher productivity of that industry. So next, next is SCADA system. I told you SCADA is a system which comprises of HMI, human machine interface, and communication interface. That is transferring data between the SCADA and the sensors, valves, etc. in those systems, and PLCs and SCADA programming and RTUs, remote terminal unit or remote telemetry unit, and the supervisory system, which is nothing but monitoring the entire process of the industry. So next. See, first PLC. It is a control. It is a controller which monitors and makes decision based on the custom program. That is the program given by the user or the program written on the PLC box. According to it, it gives commands to the system so that the process can be proceeded. And it is also used in traffic signals in changing traffic signal lights, so that SCADA is a software where PLC, those RTUs or hardwares together they make a system and controls and maintains the process continuously. So it can be also programmed. The programs in the PLC can be modified in online without stopping the PLC. The working of PLC need not be stopped for programming it. It can run by the side. It can be recoded or reprogrammed in online. And it is mostly the program language is used like ladder. Ladder is majorly used because ladder is easy language for the users to be coded, and the ladder resembles the language ladder language resembles ladder, the structure of ladder, like two vertical rails and a series of horizontal rungs between them. So as it resembles the ladder, the language is called by the name called ladder language, and 81% of the global market uses ladder language. And it is so efficient in programming. And other languages in which are used in PLCs are sequential function charts and function block diagram and structured text and instruction list. These are the other languages which is used apart from ladder in PLCs. Next, this is the basic picture of a PLC box which is used in the large industries for giving commands to the system and proceeding the process ahead. And next, RTU. RTU is nothing but a remote terminal unit. It is a microprocessor controlled device, and it is also called as a remote telemetry unit. And it have more inputs and more outputs. Unlike PLC, it needs no programming. It is already customized by the user, and it have embedded features previously, and it is larger in size when compared to PLC. Cost is also lower than PLC, but we will choose PLC rather than RTUs because PLCs are efficient, and due to the size of the RTU, it cannot be accommodated for over a large area. So PLCs are mostly preferred rather than RTUs. It can also gives command to the alarm system. If there is a chance of accidents, it can enhance the alarm system, and it can also handle the data logging, and it also controls intelligent electronic devices, that is IEDs, and it can do multiple functions as it gains the many inputs and gives out many outputs. So it is called that it is multifunctional, and it is also as I told you, it is a microprocessor controller, and which is an interface between the system, that is master system, and the objects in the physical world. It transfers data from the master system to the object in the world, and it can also gains information from the object to the system, and accordingly it gives commands to the process. And next, this is the connection which is made by the RTU with the master system. That is, most of the RTUs are connected to the master system, and it is connected to a server, and it works together to perform the process of the industries so that the productivity level can be efficient and it can be increased level by level. And next is human machine interface. It is also called as human man machine interface because it acts as an interface between a human and a machine. Human gives the data and the commands to the system to proceed the process, so it is called a human machine interface. It is an integral part of a factory because machines can make mistakes so that it can be rectified by humans. Now I'm going to say an example. You can clearly understand what is SCADA and HMI. Both are anyway similar, but it have some difference. So I'm going to explain you SCADA and HMI using this example. Take a beaker of milk. This process is this we are going to boil the milk. So take a beaker of milk, and the SCADA system is connected to the boiling of milk. Like the sensor is connected to the beaker, and the sensor, which in turn is connected to PLC or RTU, and those RTUs are connected to the master system. Master system is nothing but SCADA system, and for the first time, the input is given. Input is nothing but heating. We are heating the milk. So say at 30 degrees Celsius, the milk gets boiled. So the 30 degrees Celsius, the data is sensed by the sensor and is transmitted to PLC and RTUs. Those RTUs and PLCs send it to SCADA system. Those SCADA system store the data for the long time. If we are going to do the process again, that is boiling of the milk for the second time, the data which is already stored in the SCADA system gives the command to the PLC and RTUs, and it can issue the command orders to the process so that it can boil the milk at 30 degrees Celsius. It compares when the input is given for the second time, that is again we are heating. Also the data from the SCADA is given to the PLC, so those two values are compared for 30 degrees Celsius, and if the milk reaches 30 degrees Celsius, the process automatically stops. This is called automation. And if SCADA is not used, HMI is used in place of SCADA. SCADA is used in place of HMI. Like if human observes the temperature, that is at 30 degrees Celsius, the milk is getting boiled, so that it is observed by the human and the data is given to the system by the human. But in case of SCADA, it itself recognizes the data and stores the data and gives the command. But in case of HMI, the temperature is noted by and observed by the human, and the data is given to the system. At 30 degrees Celsius, the system should stop and the boiling of milk should be stopped. So this is the difference between HMI and SCADA. But HMI is a part of SCADA, but SCADA is not a part of HMI. And next. Next, this is the simple working of SCADA. As I told you, it receives the sensors, senses the information or the data from the process, and it converts the sensor signals into digital signals, which is transmitted by the PLC and RTUs to the SCADA, and it is stored in the SCADA. The SCADA, it collects the data from the PLC and analyzes the data and monitors the entire system with the data which is given by PLC and RTUs, and it eventually reduces the waste, and it also increases the efficiency of the system so that the product is qualified. And next, see, as I told you, PLCs are connected to HMI, SCADA, input devices, output devices. Likewise, SCADA gives the information to PLC. If the input is given by the input devices, the informations from SCADA and HMI is given to PLC so that it can issue control commands, and the output is given by the output devices. This is the process which I explained the previous slide. And next. So, according to the type of process, if we want to sense the temperature or the light, humidity, based on the process we are going to do in industry, the sensors are applied or the installed in those SCADA system, like temperature sensor and a light sensor. If light is to be sensed by the sensor, there used a light sensor, and humidity sensor, wind speed sensor, water level sensors, pressure sensors. These are the major sensors which are used in industries and factories. And actuators like motor, valve, pump, it is also controlled by the remote users, or it is also controlled by RTUs and PLCs. And next. See, what is power system automation? It is nothing but automating the power. It can work, the power system can generate and transmit the power to the all the areas without the influence of human. This is called power system automation. Here, power system automation, it uses the data from the intelligent electronic devices, that is IED, and it is also getting commands from the remote users, and also human influences will be little bit will be there, but most of the data are gained by it from IEDs, that is nothing but intelligent electronic devices, so that the generation and the transmitting of power and electricity to the areas plays a major role in power system. So IEDs, communication interfaces, and communication methods, these three work together for the better performance of power system automation. So if any one of these is not working properly, the power system may collapse and it leads to less productivity of electricity and generation of electricity. These three should be working together. So power system automation, it is also monitored by SCADA. SCADA is installed in power system automation also, and there are three main automation tasks, which is data acquisition, supervision, control. Data acquisition is nothing but acquiring data or collecting data from the system by the SCADA system, and supervision is nothing but monitoring the entire process till the end, and controlling is nothing but the commands given by the PLCs and RTUs based upon the data stored in the SCADA system. And next, SCADA in power system. So SCADA, which the function of SCADA in power system is to monitor the power generation and transmission and distribution. SCADA system is mainly installed in substations. Substations are nothing but where the electricity or the power or generator and distributed to every area. Likewise, the see the diagram. The diagram shows that equipments, the substation equipments are connected to the sensors, and the sensors are connected to PLC, and finally the PLCs are connected to SCADA, so that SCADA can monitor and gives control commands to those power systems, and it can increases the efficiency of the system by supervising, that is monitoring, and giving commands for generation and transmitting of electricity and power. So it provides, eventually it produces more reliability and stability for the power system when we are using SCADA system in power automations. And next, see, these are the main components which are in power system automation. Other than the SCADA system like sensors, PLCs, RTOs, these system components also playing a major role in power system automation. Those components are intelligent electronic devices, instrument transformers, transducers, meters, digital fault recorders. These are the components which plays a major role in automating the power system. First, we are going to see about intelligent electronic device. Next. See, intelligent electronic device, it is also a microprocessor based controller. Already told you that RTU is also a microprocessor based controller, uh, and IED is also a microprocessor based controller. And it receives data from the sensors and the equipments which are involved in the process, and it receiving the data continuously from the sensors and equipments, so that from the data it can issue control commands if the voltages and all those parameters like current and frequencies crosses the limits, so it can issue control commands by circuit breakers, capacitor banks, voltage regulators. Circuit breakers, if the voltage is high and the current is flowing, the flow of current is in huge amount, so that circuit breakers is enhanced so that the circuit is broken and the accidents may be avoided. So this is the main function of IED in power automation. See, imagine power system is of high voltage, high current, and high frequency. So high EDs must be installed there. Circuit breakers, capacitor banks are necessary so that the accidents may be avoided. Circuit breakers, it breaks the circuit when the high voltages or high current is passed through the system. So next. Next one is instrument transformer. Instrument transformer is nothing but which is used to sense the current, voltages, those parameters, frequencies from the system. It can measure the actual power system signals, which includes high level signals to low level signals. It can measure every signals which is coming out from the power system. According to that, it can give the control commands. So the general function of the instrument transformer is, suppose if you are using measuring instruments, ordinary measuring instruments like ammeter, voltmeter, it is designed to measure till 5 ampere and 110 volt, like that. It is very small value, but in case of power system there is a huge amount of voltage and a huge amount of current, so it cannot be measured by ordinary measuring instruments. So instrument transformers are mostly used to measure the high voltages and current. It can be measured only by the use of instrument transformer. So instrument transformers plays a major role, and it can standardize the ordinary instruments, measuring instruments, so that we can measure the high voltages and currents which are involved in the process like our power system. Next. And transducers, it converts, the general function is it converts the one form of energy to another form. Like in power system it controls any form of energy like pressure, temperature, and displacement. It converts the those form of energy into electrical energy. So its main function is converting one magnitude to another magnitude. So there are different kinds of transducers like temperature transducer, which converts the external energy into temperature, and pressure transducer, displacement transducer. Even speaker and antennas are a transducer, because speaker it converts electrical signals to sound waves, and antenna which converts radio frequency from the satellites and from the space to electromagnetic waves. So these are also called as transducers because it converting the energies from one form to another form. And this is a component in which the power system automation works. And next, and meter is nothing but we can see this meter in our house also. So it is used to measure and measure the voltages and current and the accurate parameters, and it can be shown to the human benefits so that they can uh, alternate the current and voltages according to the measurements given by the meter. And this is also used in power system industries for the automation process. Next. Next. Next, digital fault recorder. The name itself says if there is any disturbances in the systems or the substations, it will be recorded in the digital form, and it is given to the human or the observer. So it is mostly installed in substations. It can record all the waveforms from higher waveforms to lower waveforms. All the high frequencies can be recorded by the digital fault recorder, and it monitors the substation loads according to the waveforms. It decides the amount of load should be given to the substations, and it continuously provides the critical information that is nothing but the information which is gathered from the substations. It continuously gives it to the user so that the power disturbances and anomalies can be known and identified by the humans so that the accidents may be avoided. So DFR is installed in substations for the human benefits and to avoid the accidents. These are the main functions of DFR, and it is called digital fault recorder. And next. And at last, the advantages of SCADA. As I told you, it monitors the entire system continuously, and it is also used in detecting the fault in the system. Like if there is any outages of power, the SCADA system it helps the humans to detect the exact location where the outages is happening, and it also enables alarm system so that the users can operate and identify and rectify the fault and prevent those accidents. And it also controls the switches and circuit breakers, and if those system parameters crosses the limit, and it can control the switches and the circuit breakers so that the outages will not happen, and it is fast in obtaining response. It is quick in obtaining response, and it is widely used in telecommunications and militaries and energy transportation, oil and gas, water, etc. These are the places where the SCADA is majorly playing a role. And next, disadvantages. It is the hardwares of SCADA is complex, and the complexity can be handled only by the skilled laborers, not the uneducated ones. And it needs skilled laborers, operator, analyst, and programmers. Mainly programmers are needed so that the PLC can be programmed according for the process. And the installation cost, the cost of the SCADA installation is much higher. And the unemployment rates, if there is no influence of human, unemployment rates increases gradually due to installation of SCADA system in the industries. And the hardwares and the softwares are unique so that any other softwares and hardwares of other system cannot be used in SCADA system. The softwares and hardwares are unique in nature for SCADA system. And next. Next, these are the companies which are using SCADA system, like in our country, like India, Ovaro, formerly Sevelec Technologies and Premier, and Rotroc PLC, and Vivo USA LLC, Nivus GmbH, General Oceanics Inc., and Aquarid Limited, Challenge Technology, CKT Plus Electronics. These are the companies which are majorly using SCADA system in our country. Next. Finally, conclusion. So the automation is changing the world, and the industrial automation is uh, working in a fast way that it changing the way the world which works. And before the machines are worked, but now the machines operate by itself by the software and the commands given by the humans, so that the machine can operate by itself to proceed a process and to get a product, quality product in industries and huge factories and large organizations, like factories and industries, large factories and industries. They completely depend on SCADA system nowadays, so that the human interaction may be reduced and labor cost is can be reduced. And thank you. This is my presentation. That's all. Any queries? If you have any queries, leave it in the chat box. Thank you, sir.
Uh, my query is, could you explain a bit more about the role of a transducer?
Transducer.
Yeah.
Yes, it converts the one form of energy to another form. Like if we are giving an external pressure or temperature in the transducer, which is used in power system, it converts those pressure and temperature to electricity. This is the main function of transducer. That is nothing but it can convert any form of energy to another form, and this is the main function. Like I told you an example, like speaker and antenna. Speaker, it receives the electrical signals, so it converts the electrical signals to sound waves. So it is converting energy from one form to another. And antenna, it receives radio frequency, and also it converts radio frequency to electromagnetic waves. So that's it.
Great presentation.
Thank you.
Thank you, Aditya. Mohan Ram, you have one more query in your chat box.
Yes. PLC and
It was
microprocessor.
posted by Rahul Kumar sir.
Yes.
What was the difference between PLC and microprocessor?
PLC, it is a PLC is a controller, whereas RT is a microprocessor. PLC, it is programmed by the users, but RTUs are not programmed. It doesn't need any programming languages. It is uh, customized by the manufacturer, so that we can use what they are giving. But PLC can be moderated and alternated according to our benefits. So the programming language called ladder is used in PLC, but RTUs is not like that. It is a microprocessor based controller which is already customized by the manufacturer. That's it, sir. Clear, sir?
And your next query is from Arjunan. Mohan, please tell the short definition about SCADA just to recall it.
SCADA. SCADA, it receives the data, and using the data, it can use the command to the process. Like I told you, the boiling of milk. So, say at 30 degrees Celsius, the milk is getting boiled. So it is the data is stored for the first time. The 30 degrees Celsius, it is the boiling point of the milk. For the second time, if we are heating the milk at 30 degrees Celsius, it automatically stops the boiling of the milk, so that the data from the SCADA is given to the process, so that it should stop at 30 degrees Celsius. This is the main process of SCADA. It automates the process. That's it. You clear, Arjun?
Thank you, Mohan.
Okay.
Our next query is from Dr. V. Ranganayaki ma'am. That is difference between sensors and transducers.
Sensors is it can sense only the signals and transmit it, but transducers, it converts the signals or the energy forms from one form to another form. But the sensors, it receives the information and directly it transmitted to PLC and RTUs. But in case of that one uh, in case of in case of transducers, it is converting the one form of energy to another form. And this is the main difference between sensors and transducer. And one more thing, if the sensor is giving the sensor signals to the PLC natives, it converts the sensor signals into digital format, and those digital formats and the data and the informations, all those things are stored in SCADA system. And that's it.
We have Aditya again asking, is SCADA just like other systems susceptible to security threats?
No, not like that. It is just an automation. We doesn't have any threats and susceptible to security threats. Nothing will happen in case of SCADA system. It is just an automation.
We have Rahul Kumar sir again. What are the other advanced automation technologies available in real time?
Real time. So I have not a deep study about the real time technologies, and I have no only the overview of the SCADA system where it is used. And sorry, sir, I am not able to answer your question. Thank you, sir. Any other
Participants can
queries?
open your mic to ask your queries directly. Thank you, Mohanram, for your fabulous delivery of your speech. Thank
Thank
you
you.
for all the active participants. And tomorrow, at the same time, we have Ms. Soumya to have a delivery on a topic wireless communications. Stay safe, stay connected, and keep learning. Thank you.
Thank you, everyone. And thank you for our institution, which gives me a wonderful opportunity and highlight my talent. Thank you. Thank you, everyone.